Today we will be doing the sum from 1 to infinity of 1 over k squared plus 1. And to start off, we will use the sine infinite product formula that states that the sine of x over x is the product from 1 to infinity of 1 minus x squared over k squared times pi squared. And using this, we would take the natural log on both sides. So the natural log of the sine of x over x equals the natural log of the product from 1 to infinity of 1 minus x squared over k squared times pi squared. And using logarithm rules, we will separate this into the natural log of the sine of x minus the natural log of x equals the natural log of a product is the same thing as the sum of logarithms. So this is the sum from 1 to infinity of the natural log of 1 minus x squared over pi squared times k squared. And from here we would differentiate both sides with respect to x. So the derivative of the natural log of the sine of x is the cotangent of x, and the derivative of the natural log of x is 1 over x. So minus 1 over x equals the sum from 1 to infinity of, taking this derivative, we have a 1 over 1 minus x squared over k squared times pi squared times the derivative with respect to x of 1 minus x squared over pi squared times k squared. So we have a cotangent of x minus 1 over x equals the sum from 1 to infinity. We'll have a k squared pi squared on the top and a k squared pi squared minus x squared in the denominator. And taking this derivative, we have a minus 2x over pi squared times k squared. And the k squared and pi squared are gone. So we have a cotangent of x minus 1 over x equals the sum from 1 to infinity of minus 2x over k squared pi squared minus x squared. And multiplying both sides by a factor of minus 1 over 2x, we have a minus 1 over 2x cotangent x minus 1 over x equals the sum from 1 to infinity of 1 over k squared pi squared minus x squared. And distributing that negative, we have a minus cotangent x over 2x plus 1 over 2x squared equals the sum from 1 to infinity of 1 over k squared pi squared minus x squared. And then from here, we'll make a transformation from x to pi x, which we have the following. We have a minus cotangent of pi x over 2 pi x plus 1 over 2 pi squared x squared equals the sum from 1 to infinity 1 over k squared pi squared minus pi squared x squared. And factoring out a pi squared, we have a 1 over pi squared times the sum from 1 to infinity of 1 over k squared minus x squared equals negative cotangent of pi x over 2 pi x plus 1 over 2 pi squared x squared. And then multiplying both sides by pi squared, we have that the sum from 1 to infinity 1 over k squared minus x squared equals pi squared times negative cotangent of pi x over 2 pi x plus 1 over 2 pi squared times x squared. So distributing that pi squared and simplifying, we have sum from 1 to infinity 1 over k squared minus x squared equals, we'll have a minus pi cotangent of pi x over 2x plus 1 over 2x squared. And then from here we will plug in x equals I. So if we plug in x equals I, we have the sum from 1 to infinity of 1 over k squared minus I squared is the same thing as the sum from 1 to infinity of 1 over k squared plus 1 equals negative pi cotangent of I pi over 2I plus 1 over 2I squared. And this simplifies into a minus pi cotangent of I pi over 2I. I squared is minus 1, so we have a minus a half. And then from here, we'll use the following well-known identity that the cotangent of x is the same thing as I times the hyperbolic cotangent of ix. So using this, we'll plug in x equals I pi. So that means that the cotangent of I pi is I hyperbolic cotangent of I times I pi, which is the same thing as I hyperbolic cotangent of minus pi. But the hyperbolic cotangent is an odd function, so this is minus I hyperbolic cotangent of pi. So using that cotangent of I pi equals this, we have a minus pi minus I hyperbolic cotangent of pi over 2I minus a half. And as you can see, these negatives will turn to a positive, and this I will divide to 1. So we have a pi hyperbolic cotangent of pi over 2 minus a half. So now we could say that therefore the sum from 1 to infinity of 1 over k squared plus 1 is equal to pi times our hyperbolic cotangent of pi over 2 minus a half. And so this is the final result.